Welcome to the Modern Biopharma Podcast. The world of today's medicines is big, complex, and constantly changing. Our goal is to give you insight into the people that are manufacturing the medicines people need every day, whether it is the people taking care of these facilities, or those building them, or those maintaining the quality and integrity of every dose that is delivered to the patient. We interview the people that are making it happen and give you a chance to get to know them while we're at it. Thanks for saying hi. Hello, everyone. Welcome to another episode of the Modern Biopharma Podcast. This is Jesse, and we are here today with Jeff Wassenaar of AstroPak. How are you doing today, Jeff?
Hey, doing well, Jesse. Thanks. Appreciate it.
Awesome. Well, I'm glad to have Jeff on today. We're going to be talking about cleaning and passivation. It's a big issue, big thing that people talk about, need done at their facility in the pharma world and other industries, but we're going to talk about pharma today. So Jeff is the Vice President of Field Services Sales at AstroPak. He's been with them for how many years you've been there now?
11 going on 12, believe it or not.
Years. Yeah. All right. So he's been there quite a bit. Yeah, I know he started managing a territory in the Midwest and grew it and and then took on national sales role. And now the new role is Vice President of Field Services Sales here at AstroPak. I did a short stint at AstroPak working for Jeff, so that's how I know Jeff, and I'm very familiar with his living room there in the background.
Yes.
We used to have video calls together, so not the first time I've seen him on screen there. So we're gonna just sort of go over some of the basics of cleaning and passivation, and other things that are done in that world in the pharma space. Jeff gives presentations all over the U.S. and has for give or take 11 years now, right?
Yeah.
I know because I got to be part of them. I really like the presentations that AstroPak does. They do a really good job of laying out sort of the science, the practical side of things, and you get to really see what's going on in their presentation. It's not boring, and I've really enjoyed seeing those over the years. So we're going to get right into it and just learn a little bit more about you first, Jeff, if we could. Could you just share a little bit about who you are, where you're from, things like that?
Sure. Yeah, I live in Michigan. I usually tell people, though, that I live in an airplane, except for these days. Our company's based out of Southern California, and we have offices all over the country, 11 different field operation shops. And so I have the pleasure of leading the sales group, and we have salespeople all around the country, down to Puerto Rico and Mexico City. So
awesome.
My background, I came out of right out of college. I went into the semiconductor industry, and then from there I got involved in our family business, which was construction, and did that for a number of years. Spent a little time in the metals industry. And then, with AstroPak for the last 11 years. So it's been a good ride.
Awesome. So what's something that you like to do in your spare time, maybe during the summer as it gets a little bit warmer?
Yeah, I think you know the answer to this one. I love boating. Lake Michigan is awesome, and so we spend as much time on the weekends as we can out enjoying that. So.
Yeah, I'm a little jealous. I've seen your boat, never been on it, but ooh, it's a nice boat. I don't even have a kayak, so I got nothing. But I think you could have a small army meet on your boat, so it's pretty awesome. All right, cool. Well, we're gonna get right into it and start talking about cleaning passivation. I guess first thing I'm interested in sort of getting your feedback on is, how do you feel like the overall knowledge of cleaning and passivation is in the pharma industry?
Yeah, I'd say it varies. I think most people know they need to do it, but there's many that don't know why exactly. So it's a lot of fun as I travel around and talking with folks, just to kind of get those varied responses.
Yeah. So why do you think that? Why do you think people don't know why? I mean, it's done commonly. People are used to seeing companies like AstroPak come in and do it.
Right.
So why is it a mystery, do you think?
Yeah, I think that's a good question. I think that there's a misconception of what it is. I think some people think it's some kind of a magical coating or something like that that's on the surface. And where I usually start my presentation, and I'll ask this to you, Jesse, if it's all right. How much iron is in stainless steel in the base metal? Any idea?
More than you think. Is it 60%?
Yeah, you've heard my talk, so it's probably not a fair question. But yeah, it's funny. It's between 64 and 68%. We're talking 300 series, and a lot of people don't know that though. I'll go and talk with groups, and there's a lot of groups that will, they'll kind of sheepishly guess 10%, maybe 20% or whatever, and they're quite amazed to find out that it's almost 70%. And so that's kind of where I start with it. And once people understand that, it kind of helps the pieces, of the puzzle come together. So I told you I spent a little time in the metals industry, and if you look at the base metal of stainless, that's where all that iron is. But the cool thing about stainless is as you get closer to the surface of the metal, things start to change. The metallurgy changes. We hit this nickel enrichment area. And we like nickel because it's hard and it gives us our pitting protection. And then you get to the very surface and you get the chromium. And chromium gives us some general corrosion protection. And that's where we establish the passive layer. So.
Yeah, it's funny. Funny you asked me that. I got nervous there for a second. I'm like, oh shoot, I hope I don't mess this up. But I have when I was with AstroPak, but other times as well, had discussions with people in the industry, and I think I've heard people say there's no iron in stainless steel. You're like,
right.
Oh, I don't know why it would be called steel, but okay.
Yeah.
And I've heard people, very, intimate with stainless steel for their whole careers, basically say there's almost no iron in stainless steel.
Right.
So it is kind of an interesting dynamic there for sure.
Yeah.
So, okay. So you just talked about the layers that you have. So you got this heavy iron component to stainless steel, despite what many people might think. And then you have these layers as you get closer to the surface with nickel and chromium. So what are we talking about when we say passivation? So what is this magical passivation layer, and why is it important in stainless steel?
When stainless steel comes out of the mills and we buy it, it's basically passive for all intents and purposes. But it's the things that we do to it in fabrication. It's the grinding, the sanding, the polishing. It's all of those things that make us need to passivate. So why is that? What we do in passivation, it's really the final step where we clean the free iron from the surface of the metal. So I had said that chromium's at the top of the surface, right? So what we do in passivation is we clean that surface off, and we remove the free iron from the surface, and we leave behind the chromium. And if you do any study on passivation and in stainless steel, you'll hear a term chrome to iron ratio. I want more chrome than iron at the surface. And the more chrome that I have than iron at the surface, the better passive layer I have. So that's really the magic of it from that end.
Okay. So, why is chrome more passive than iron?
So
you got iron oxide, you got chrome oxide, you got, right? So
right. So what the chromium does is it slows the corrosion, gives you corrosion resistance. So the thicker that film is, or that layer, you're going to slow that corrosion rate down. And so what does that do for the site? It gives you longer maintenance intervals, and just slows there's no way to stop the corrosion with stainless steel. Some people think, hey, I passivate it once, silver bullet, I'm done. And it's not that way. Stainless steel will eventually come back and corrode and cause issues. And the particles are really what we're concerned with in this area. So.
And the particles that we're talking about, or we're talking about metal particles, or
particles, iron oxide particles that would get into the system and wherever that system takes it. And of course, what we worry about, and certainly from an audit standpoint, we worry about visible particles, right? So that's really what happens in passivation. So let's say you have a new system. I bought all this stainless steel tubing. We welded it up and all that. Why do I have to passivate? It's the welds in this case.
Mm-hmm.
So what happens is when I weld on the surface of stainless, I bring all that iron up to the surface and I change the metallurgy. So if I don't passivate that weld, it is going to immediately start to oxidize. So what is iron oxide? Iron oxide is rust, corrosion. We don't like to call it rust in the pharma world. Rust is on the outside. Rouge is in the inside, so we call it rouge. That's right.
Yeah, awesome. So another thing that's closely related to passivation that we talk about in this space is derouging. So you just said it's not rust, it's rouge, totally different. We're not talking about the same thing. It's rouge. Okay. So how is something like derouging different from passivation? And then another word that comes up in these discussions a lot is something called pickling.
Right.
And a lot of people seem to use these words interchangeably. So could you talk a little bit about, first off, what's the difference between derouging and passivation, and then maybe what pickling is and maybe why people would use them interchangeably like that?
Yeah. Good question. So passivation, as I mentioned, is just the cleaning. It's the final step where I'm cleaning that free iron from the surface. And derouging is a little different. So I have a little sample here of an impeller. And this is an impeller that we dipped in for just illustration purposes, but the impeller was all rouged up like you see here.
Yeah.
And we put it in the chemistry and cleaned, took the rouge off. So basically, what passivation would not remove this rouge. It's not going to do that. You can't passivate over the rouge or through the rouge. So I have to derouge that. And derouging, I'm removing the metal oxide from the surface. And with that, I'm going to be using a little more aggressive chemistry, right? And that more aggressive chemistry is going to remove a little bit of heavy metal into the solution that we're circulating. So passivation does not remove any heavy metal. You can passivate, all day long, and you're not going to remove heavy metal. You're going to just remove that free iron. So the derouging does remove that color. So I have a lot of customers that think passivation is going to remove heat tint from a weld or something like that, and it will not do that. You have to get more aggressive and go after that. So the difference between derouging and pickling, they're both removing some heavy metal, but in the pickling situation, you're removing a lot of heavy metal. You're etching that surface. So pickling, if you think of it this way, pickling can be done one of two ways. It can be mechanically sanding that discoloration from the weld or the surface, or it can be done with taking chemicals and etching that heavy metal off. So that's really the difference. So yeah, when our people get somebody that calls and says they need something pickled, we're usually asking a few questions just to make sure that we're on the same page.
So that's kind of a square is a rectangle, but rectangle isn't a square kind of scenario. So pickling technically would derouge, but it's not really what we're talking about when we're talking about derouging.
Yeah, if you have a highly polished piece of stainless steel or vessel or something like that, and you pickle it, chances are somebody's going to be pretty upset at you because you've etched that. Yeah, you've etched that surface. Not good. So
okay, all right. So so again, people even in this industry use those two words interchangeably. So is there circumstances where you actually are doing pickling in the pharma space, or is that really just a bad term?
Yeah, pickling is done more in the pharma space on exterior surfaces.
Okay.
So if I've got some like a mezzanine area, and I'm taking and removing some, embedded metal into the surface, and I want to remove that. I can do that with pickling. So it's more on exterior surfaces and things like that.
Okay.
Not product content.
And it's more of a how things look versus like a chemistry and making sure things aren't getting into a product and stuff like that. Yeah. Okay.
Speaking of exterior surfaces, there's a lot of folks that, if they have an audit happening, if I see it, if somebody sees it on the outside, what is on the inside, right?
Mm-hmm.
And so there's a lot of more attention being paid to the exterior of things now. And so taking care of that. Now, some sites will have, folks go around with, a greenie or a Scotch Brite or whatever. And yeah, they'll remove that rouge or that rust from the surface for a little while, but
it's rust
yes,
on the outside.
that's right. That's right.
Let's get it right. Okay.
Thank you. So the rust from the outside, they'll remove that temporarily, but what they've really done is they've basically ground that iron oxide into a bigger area. It might have been a small area when they started, but they've just rubbed that into a big area. So they'll come back a few days later, and all of a sudden, I've got rouge in a bigger area now. And so we do a lot of that exterior remediation using different processes. If we do use something where, like a Scotch Brite, we're following it with gel passivation to remove that iron from the surface so that we don't exacerbate something like that.
So is that, we're we talking about like the feet, or is this all kinds of surfaces, or do you typically see this in specific type of places?
Really any exterior surfaces. I mean, the sky's the limit on, where this would be in a, water room or anywhere in a facility where you've got stainless steel.
Okay. I didn't know if you had maybe typical places where it pops up more than others.
Yeah. We've done trim around doors and base moldings and ceilings, all kinds of different things like that.
Right. And I mean, there's a lot of tough chemicals like spore cleanse, it's a great thing. We need it, but it's pretty tough on stainless, right? So
yes, yeah, it'll actually cause more issues, from from corrosion and things like that. So yeah.
Okay, cool. So so we've talked sort of generically about how passivation is done. A little bit about the chemistry. We haven't really talked to the chemistry specifically yet, but so what are the processes that you in the pharma space that you spend the most time doing derouging, passivation? Just any kind of stainless at all in the whole facility, or where are you doing most of this work?
Well, a lot of the work is in the critical utilities area. The product contact vessels, media, buffer, bioreactors, things like that, for sure. So, and we're doing that through generally through circulation. We have applications of, whether it be circulation or spraying or gelling, on the surface and that sort of thing. But in most scenarios, when we can circulate, that's what we prefer to do.
Okay.
And so in that case, we're bringing in a portable CIP skid of our own. It's got everything on board, pump, heat exchangers, all the gauges, filters, all that sort of thing, where we're rolling that into the critical utility area, wherever, the site allows us to set up, and we're bringing in our hoses and connections, and we're connecting into a system and creating a circulation. And yeah, that's how we do it.
So why isn't, I'm just curious, like I know there's CIP systems for all kinds of equipment in a pharma a plant. So why is this not something that is automated, set up in advance for a facility?
Yeah, that's a good question. And CIP certainly, is a good thing and is used in all the facilities we work in for the most part. But and there's times where we'll use a CIP system and inject our chemical into it. But the reason why it's not widely used in general are for a few reasons. The CIP system would have to, you'd have to change the software to be able to give it some different circulation times, because with our chemistries, we need contact time and temperature. And so that would be one reason why that wouldn't happen. Different chemicals, one size doesn't fit all in this area. And so there are different chemicals that work better in different things. There are some commercial available products out there that kind of help things keep at bay. But at some point down the line, things are going to get beyond the ability to handle it with, the smaller guns, and you need some bigger guns to be able to take care of something. So, and then here's the big one: increased volumes. If you're using if we use a site's pumps or their CIP system, we have to worry about cavitating their pump or whatever. So typically, we're bringing in 10 to 20% volume of to get through their system. Whereas if we brought our own portable CIP skid unit, we can go 5% or even a little lower. And that's significant when you think about the chemicals and the costs and the disposal. All of that it's a big deal.
Interesting. Okay, cool. So we didn't touch on it, but I just want to real quick. So like when we talk chemistry, passivation is cleaning the little bit of free iron off the surface. It's not cleaning iron oxide off the surface. So there's there's chemistry for that. And then there's derouging. There's a different chemistry for that. There's a different chemistry for pickling. So can you talk to just what some of those are typically? And I think there's some basics, but there's probably some variation within these as well. Can you talk to that a little bit?
So from a passivation standpoint, there's usually 3 chemicals that come to mind. And that would be nitric, kind of the standard bear, been around for years. Great oxidizing acid, but very harmful, hazardous, for humans and epoxy floors and things like that. Phosphoric is sometimes thought of as a passivator. We don't look at it as a passivator, and I'll explain why. It's great at removing light rouge. We think of phosphoric more as a derouger, not as a passivator. Okay. And then the third one is citric chemistry, and that's really where the science and technology has gone to the citric blends. We get the best results, the highest chrome to iron ratios with the citric blends, it's a chelating acid, so just so many benefits to it. We can adjust pH as we're circulating, and in most municipalities we're able to go to drain. Again, there's no heavy metals. Now when we go to other things like derouging, then we're still using a citric based chemistry, but we're adding some intensifiers, whether that would be EDTAs or oxalics, that sort of thing. But just to depending on the system again, for any polished systems, we don't want to etch that surface or harm that surface in any way. With a clean steam system, we're getting more aggressive with that. Clean steam, if you're familiar with it, is a steam that looks like this, kind of a black gray look to it, and we can clean that off and do every day, but that's taking a more aggressive chemistry, a small percentage of ammonium bifluoride, and so different approaches. So there's certainly not one size fits all, for sure.
So I'm curious, on the steam side, you just showed me a steam one. How common is that right now? Because I had a background before I was ever with AstroPak, and I've been around the water for a long time. And my thinking was always like, well, if there's no water in the system, then how is it going to carry any particles really, like, to a significant degree? Technically, yes, some particles go, but it's tiny. So like, how many places are still derouging their steam systems?
Yeah, so good question. And the answer across the country is clean steam systems are derouged every day. We do them routinely. I'll give you an example. On the East Coast, we had a customer who we were quoting a shutdown for them, and the clean steam portion of it, they decided to pass on it. The cost, or whatever associated, the hassle or whatever, and they passed. Less than a year later, they were finding visible particles in their clean condensate, and that's a big deal if you're seeing
Yeah.
visible particles. So they called us, and in an emergency situation over a weekend, we went and cleaned it up, and they were very grateful to get rid of that. I have seen, for other examples, when I've done job walks at facilities where you can see almost a splatter effect where something is steamed, a lyo or an autoclave, and you can see the rouge has been deposited on the surface of that equipment.
Mm-hmm.
And so sometimes people will say, hey, come clean my lyo, come clean my autoclave. Yes, we can do that. But where's it coming from? And let's look at clean steam. And so there's a myth out there that says, don't worry about that black steam. It's really a protective layer. And I don't have the pictures to show you right now, but on our website, you can find some information. But it basically, if you look at this black gray rouge through a magnified.
It looks totally silver in this for some reason.
It almost, okay, sorry. To me, as I look at it, it almost looks like black Rust-Oleum was sprayed on there.
Yeah.
And but if you look at that highly magnified, you actually see that rouge is growing in crystal structures. And you can see the base metal through those crystals. And eventually what we've seen, and we know it's true because you find it in the condensate, is those crystals grow, and then they slough off. They may attach in another part of the system or on an autoclave or a lyo, or you certainly don't want it traveling around. So anyway, so yes, we're doing them all the time. It's we have to bring more hose to create our circulation, because again, we're creating circulation, and a clean steam system is not a circulating system. So it's something that we're very used to doing and setting up. So
okay. So I'm actually curious. I didn't put this on my list of questions for you, but I'm curious if anything's come up with this. I know a lot of places do passivation, derouging on a schedule, right? They say every year, every 2 years, every 5 years, depending on whether it's hot or an ambient loop or whether it's steam. So is there anything happening or any kind of monitoring taking place at many customers where they're actually going, I'm looking for this amount of particles? I think on paper that exists, but I'm just curious, are you actually seeing places do that?
Yeah, we've helped some facilities come up with more of a scientific approach instead of just the arbitrary frequency of 2 years or 3 years or whatever the case may be. And so it takes some time to get the data. We can take water samples from systems and analyze the particles and look at them on a monthly or quarterly basis and see them change in not only size, but in quantity. And you can do that by collecting those through a filter pad and then doing a particle count analysis on that. So yeah, there are some that have gone to that. There are some that have used Rouge monitors. At the end of the day, I would say that still the majority of customers still use the arbitrary, situation, but more and more we're starting to see customers thinking about, hey, is there, can I put some more science in this, or, do some analysis? And so we're happy to help out with that however we can.
All right. Awesome. Yeah. I think that's with some of the other stuff, I know I'm in the water space, and there's more and more monitoring coming up in different things that we never thought would be able to be monitored sort of, online versus even taking, say, samples and sending them out to the lab like you probably do for a particle size analysis. I'm just curious if that was something that would be growing in the space in regards to when you decide to passivate or derouge. So
Sure.
So another question I have, and this is a thing around the whole industry, is more and more facilities. This has been the next big thing for the last 20 years, is single-use facilities. So in single-use facilities, a lot more plastic, a lot more disposable, obviously. So how is that like where does, a service like AstroPak provides, where you're doing cleaning and passivation, how does it fit in? How does it change? Are there new things that you guys are doing, basically because of that, instead of, everything being stainless steel?
Yeah, there was a lot of talk about that, and some people concerned, how that was going to affect things. But really, what it boils down to is it affects the bioreactor, right? So it affects that. It affects the clean steam, or the SIP or CIP. Steam that's needed in those areas is reduced a little bit, but we still have stainless steel media tanks, buffer tanks. We still have stainless steel in the critical utilities area. So has it affected? Certainly, but not to the level of anything that's been huge for us. I mean, we're still partnering with folks on all those other things. So
okay. How about like on the ambient side, more places are going to say ambient water systems versus heated water systems. Have you seen any kind of changes as a result of that? I mean, maybe I would assume that the Rouge doesn't build up as fast, but I don't know, maybe you end up with more, bio remediation projects. Have you seen things like that?
Yeah, it is. It's one of those things where, the hotter the system, the more, corrosive. Every 10 degrees C, you raise in temperature, you double the corrosion rate type of thing. So the ambient systems, to your point, are, we still derouge those, probably more on a, 5 to 8 year, type of situation. But it depends on the water quality and all kinds of different things, right? But you're exactly right on the bioburden side and biocleaning side, and so that's an area that we're doing a lot of work in that whole end of things, and we've come up with some really good processes for biocleaning and bioburden removal. So.
Well, we'll have to do a different episode on bio cleaning and removal.
I'll take you up on that.
Sorry, I didn't have any questions on that one today.
No, I'll take you up on that. So.
Yeah, we have. I did a whole episode in regards to microbiological monitoring in ambient systems. So I know that's a big deal, and people are really starting to set into that. Now that you can use RO systems to make Wi-Fi instead of just stills, so that's been kind of a big deal, and it's growing a lot. So.
Sure.
We'll see how the remediation part of that takes place after the fact.
Right.
So, all right. Well, I think that's all I had for questions. Is there anything else you'd like to sort of throw in there as a final word on passivation and derouging? And
no, just super impressed with your podcasts, and have been watching, been kind of following those, and so just a good way to connect people during these times. And I'm looking forward to brighter days ahead. We're seeing signs around the country where people are getting back to work, and facilities we're definitely doing shutdowns and normal maintenance work now. So that's just kind of fun to see things getting a little bit more back to normal.
Yeah. Well, that's good.
Appreciate it.
Good to hear.
Thanks, Jesse.
Thanks, Jeff, for being on today, and we'll see you on our next episode.
All right. Thanks.
All right. Thanks again for listening to the Modern Biopharma Podcast. Please reach out if there is someone you'd like us to interview or a topic you'd like us to discuss. We will make it happen. And don't forget to like us on iTunes or subscribe on YouTube. It helps us get the word out. See you next time.